Now we're going to continue solving system of equations using yet another technique. We studied substitution technique, elimination technique, solving using matrices using what's called Gaussian elimination. I don't think I mentioned that. Now we're going to talk about solving systems using determinants and Cramer's rule. Let's first learn how to take the determinant of 2 by 2. Very simple. These bars mean determinant. The determinant of a 2 by 2 is simple. Multiply those two numbers, minus, and then multiply those two numbers, and use arithmetic. The determinant of 3, -2, 4, 5, why that's going to be 23. Because this product is 15 minus, and this product, 4 times -2, is -8. And that's 15 plus 8, or 23. Finding the determinant of a 2 by 2 is very simple. To get it wrong is because we didn't multiply right. Those two numbers multiply out to -16 minus these numbers multiply out to 20. -16 minus 20 is -36. You have to know how to add and subtract and multiply, actually just subtract, and multiply sign numbers. Now, we're going to solve a system of equations using Cramer's rule, which uses determinants. If you have 2x plus 3y is equal to 5, and 7x minus 8y is equal to -1. We want to solve for x. In the bottom goes the determinant of just this. The coefficient matrix. 2, 7, 3, -8. And in the top, you get the exact same determinant with one exception. Remember, x's and then y's. X's and then y's. Since we are solving for x, the x numbers are wrong. You put the right-hand numbers instead. In the bottom, you get -16 minus 21, which is -37. In the top, you get -40 minus a -3, which is -37, which is 1. X is 1. If you wanted to find y, the bottom determinant is just the coefficient. 2, 7, 3, -8. 2, 7, 3, -8. And we just did that one. We did it right above, and we got -37. For the top, it's the same, with one change. If you're solving for y, you erase the y column, and you put the right-hand numbers, 5, -1. And you get 2 minus, minus 35, which is -37, over -37, which is 1. X is 1, y is 1. Let's do one more. The denominators never change. It's the numerator that changes. When you're solving for x or y, the denominators never change. 3x minus 1y is equal to 2, and 7x plus 3y is 11. If you want to solve for x, the bottom determinant will be 3, 7, negative 1, 3. In fact, if you want to solve for y, the bottom determinant is the same. The top one changes. Since I'm solving for x, the first column, this column gets replaced with 2 11s. The other column stays the same. When you want to solve for y, the y column in top gets changed. It becomes 2 11. It's as simple as that. Two times 3 is 6, minus 11 times negative 1 is negative 11. That's 17. The bottom, 3 times 3 is 9, minus 7 times negative 1 is negative 7. That's 16. So x equals 17 over 16. Now, we know what the bottom is. It's 16. Because if you look, it's the same determinant. Okay, the numerator, that changes. 2 times 11 minus 7 times 2. Okay, 8 over 16 to the half. Y equals a half. X equals 17 over 16. Problem is that doesn't seem to be working. 51 minus 8 is 43. That's right. 6 minus 11. 6 minus negative 11. Oops. I changed the first column by error. It should have been 3, 7. So it's 30. 3 times 11, of course, is 33. Minus 14 is 19. So it's 19 over 16. Let me check that, please. 51 minus 19 is 32. That worked. 70 and 119 minus 57. 70 and 49 plus 57 plus, excuse me, 176. Yep, that's it. 17 over 16 and 19 over 16. That's how you solve 2 by 2s. Very mechanical. I see students, they take the exams and they come in not knowing the rules. The rule's straightforward. They do the determinant backwards, 2, 3, 4, 5. They do 12 minus 10. No. It's this product minus that product. First, second, start. Do this first, do that second. That's one way of remembering it. Now, let's talk about 3 by 3s. 3 by 3s are done the exact same way, except taking the determinant of a 3 by 3 is very different. The level of difficulty isn't bad at all, but it's different. If you want to calculate this determinant, those are 2s. what you do is write it down again. Try to be neat and line things up nicely. Now repeat the first two columns at the end. 172, 221. Now, it's going to be one thing minus another thing. Oops. 221. Get rid of that. It's this product, which is 4, plus this product, which is 0, plus this product, which is 21, minus, now we go the other way, this product, which is 12, plus this product, which is 0, plus this product, which is 28. So it's 25 in here, minus 40 in there, minus some silly arithmetic calculation, it's negative 15. It's called the tic-tac-toe method. The easiest way of calculating a 3x3 determinant. So now, let's do an example. You have 2x plus 3y minus 4z is negative 2, and 3x minus y plus z is 4, and x plus y plus z is 2. Negative 2, 4, and 2. Okay, you have this. If you want to solve for x, the division of two determinants, just like before. The bottom determinant is the coefficient matrix. 2, 3, 1. Numbers in front of y are 3, negative 1, positive 1, and in front of it z, negative 4, 1, and 1. The top is going to be the same with the same exception as before. You want to solve for x, the x column, the first column, is wrong. You use these numbers, negative 2, 4, and 2. And for the record, if you wanted to say solve for z, the bottom determinant is the same. 2, 3, 1, 3, negative 1, 1, negative 4, 1, 1. But the top one changes. Only the z column changes. 3, negative 1, 1. The z column gets the right-hand numbers. Negative 2, 4, 2. And you calculate these two determinants, you divide the numbers, and you're done. Okay, let us solve for x. Let us find the bottom determinant. Let's find this bottom determinant, which happens to be the same in z and y. They're always the same. 2, 3, 1. 3, negative 1, 1. Negative 4, 1, 1. And you repeat the first two columns. You repeat this column and then that column. 3, negative 1, 1. Then you play tic-tac-toe. That product is negative 2 plus this product is 3 plus this product is negative 12. So rather than adding negative 12, let's just take away 12. Minus. Now you go the other way. This product is 4 plus this product is 2 plus this product is 9. And that's it. This is negative 11 in the first bracket minus 15 in the second bracket. It's negative 26. So the bottom for both of these are negative 26. To solve, now we have to figure out what the top determinant is. So, we go back to space, we erase all of this, and we redo it. Negative 2, 4, 2, 1, negative 1, 3, negative 4, 1, 1. Repeat the first two columns. 1, negative 1, 3. You multiply, you get 2. You multiply, there's a 1 there, you get 6. You multiply, you get negative 16. Minus, you multiply, you get 8. You multiply, you get negative 2. And then you multiply, and you get positive 12. 8 minus 16 is negative 8. Minus 6 plus 12 is 18. And negative 26. Negative 26, you divide the same two numbers, you get 1. If you want to solve for z, we already have the denominator. Just find the top determinant. If you want to solve for y, the bottom determinant is the same as the one for x and y. I mean for x and b. It's negative 26. The top determinant is, well, you take the bottom, you take the coefficient 1, and then you modify it. You're solving for y, you say, oops, you cross off the y, and the right-hand numbers happen to be negative 2, 4, and 2. Find that determinant, divide it by negative 26, do your arithmetic, you'll be done. That's Cramer's rule for 2x2s and 3x4s. And they're exactly the same procedure in terms of setting it up. What varies is how you calculate the determinants. There's only 2 of them. There's a completely different technique that one would use for 4x4s and 5x5 and saying bigger. But you're not going to see that, don't worry. Okay, that completes the section.